Yeah, so I don't get it though. I mean, who would have thought? I mean, so you got two people are going to be in this boat. So me, I mean, I know I seem petite, but in real life, I'm a little bit big. Um, and then this other little guy, and I mean, it seems like an inflatable raft is a reasonable, it's a reasonable approach. Yeah, I hate when my wife's right. I got that on tape, so I get brownie points. All right, so homework assignment. We were to expand our do math to work on an infinite number of inputs, right? Still only supporting plus signs, but now instead of just some number followed by a plus followed by some other number, it can now have an infinite number of additional plus some other numbers, plus some other numbers, plus some other numbers after it, correct? Is that what we were supposed to do? All right, how did that go? Touch and go? All right. Good, it was supposed to be touch and go. All right, so let's kind of think about this. Let's go and design our solution first, because remember we talked a little bit last time about how important it is to understand the problem first, then understand the solution as a person, then we can go and actually code it, write the software for it. Okay? So let's I didn't want that one. I want this one. Let's shrink this down a little bit. Okay, so up to this point we had something like 125 plus 7, and that worked, correct? That got us a 132, no harm, no foul. We're good with that? Okay, and let's think about how we accomplished this. We used two variables. Well, we used a couple more than that to do the conversion and stuff, but largely we used two variables. We had a variable called, we call it left, was it left op? Okay, and another variable called right op. Okay, and what we initially did is we walked through our string and we built up left op. So 1, 2, 5, built up that string, converted it into a number to work with it. So ultimately we had 125 stored in left op. Okay? Then we get to right op. So we knew when we finished reading the left op, we knew we were done when we hit the plus sign. Correct? That was our alert that we had just finished reading in the left operator. If we hit a plus sign, we know we always are going to have a right operator. So the next thing we then will read in is the right operator. Okay? 7 in this case. So we went through, we read in the 7. And at that point, we knew we were done, but we knew we were done. Why? Because we hit the end of the string. That's when we knew we were finished. Okay? That's not necessarily going to be the case anymore. Okay, so we're going to have to adapt this a little bit. All right? Then we did the math, and the math in this case is 132, right? We returned it from our function and then displayed it somewhere else. Okay? But what I'm going to suggest we do now is I'm going to suggest we take that 132 and store it back in left op. Okay? We're going to hold that number in left op. Because what are we looking for next? If we did have another plus sign, now we know that I need to go and find a new right op. Every time we found a plus sign before, we knew we already had left op. So when I hit a plus sign again, I need a new right op. So that's when I'll rebuild this guy. We'll read in the 14. We'll do the math, which is 4146. Store it back in left op. Zero out right op. Now we can handle another plus sign if we want. Plus 10, so on and so forth. So every single time we're going through our string, what we're doing is we're looking for either the end of the string. When we're at the end of the string, we know we're done. Done doing math. Final answer is where? Inside of left op. Similarly, if we hit a plus sign, we know that our running total, the current final answer, is in left op, and we know we need to build up a right op. So we're only going to build up a right op when we hit a plus sign. If we hit the end of the string, we know we're done and the final answer is in left op. Make sense? All right, so we need to now modify our code to not give up. See, right now we stop at the end of our right op, and as soon as we run out of the string, we now need to ask a very similar question to what we asked when we were building up our left op, and that is, are we looking at a plus sign? Make sense? As long as we keep having plus signs, we're going to keep reading new right ops. But we only read a left op in once to kind of get the ball rolling. Make sense? Only going to read in left op once. So let's go and look at our code here. All right, so this string to int thing, that just takes in a string, converts it to an int. We don't need to worry about that. Same jazz that we had last time, unrelated to what we're trying to accomplish. All right, now, do math. We have our left op, we have our right op, and then we have our op pause. We still need our op pause, even in our model here, because we need to know where we're going to pick up to go start reading our right op. Okay? And we're going to keep reading our right op until we either hit the end of the string or we hit a plus sign. If we hit a plus sign, we know there's going to be another right op. Before we get there, we have to do the math, store the result back in left op. If we hit the end of the string, we know we've got our final right op, do the math, store the result in left op, and then ultimately break out of the whole rigmarole and return left op. All right, so what we're doing here is we're actually leveraging left op. See, down here we're doing our math at the time when we're returning. Okay, so at the very end, so what we do right now is we read in our left op first. That's this first loop. Keep going until we hit a plus sign. As soon as we hit a plus sign, we'll store the position of the operator and then break out of this loop, which takes us right here. Then we know, so if we were to label what this loop does, this reads in a right operator, correct? But now we need to modify this. We might want to read in multiple right operators. Okay, so now as this guy's going, we're going to start with op pause plus 1. We're going to keep going until the length of the formula. But that's not necessarily true anymore. This is as long as we might keep going. But we need to now ask a very similar question to what we did up here. If what we're currently looking at is a plus sign, we know that we have to do some math and then jump back to the loop again. Does that make sense? And what does that mean? Well, count down here, I started off at op pause plus 1. I can reset I inside this loop. All right? I can reset I inside that loop. We know we're going to keep going up to the end of the string. Eventually we're going to run out of crap to look at. Okay? But each time through this loop, right now, we're just assuming that everything we read is the part of the right operator, from here all the way to the end of the string. But now I know that's not necessarily the case. As I'm reading through this guy, and I'm currently working on this right operator, I actually hit a plus sign way before I hit the end of the string. And when I hit that plus sign, two things happen. I do the math up to this point. I set the new position of my operator, and I set I equal to operator plus 1. So that the next time through my loop, I has a new value. Okay? But we need to take advantage of how for loops work in this case. And that is at the end of a loop, so this guy's going to be a for loop. At the end of that loop, it's going to add 1 to our I. So rather than setting op pause to I plus 1, we're going to set it equal to I. Then let the loop add 1 to it, which then means that the next time through, I will be sitting right at the beginning of our next right operator. Okay, to kind of take you through that logic there. So this is starts at bucket 1, right? In Blockly. So this is bucket 1, bucket 2, bucket 3. That's our left operator. We hit our first op. So that's at bucket 4. Okay? We only read in our left operator one time. So here we'll we'll go ahead and walk through this. This is 125, and then what we call op pause, something like that. All right, so then we're going to set op pause as being 4. That's going to put us right there. Our second loop, that is the loop that reads in, we're going to, instead of saying it reads in the right operator, we're going to say it reads in the next right operator. It's going to start at op pause. Oh, I'm sorry, I put op pause in the wrong place. It's going to read in from op pause plus 1 right here, all the way up to either the end of the string or the next op. So we read in the 7, and then we bump into an operator. Okay? That's our if statement that we have to insert. If we're looking at a plus sign, that means we are done reading the current right op. And we've been building the current right op inside of right op, right here. We've been building that up. Then we hit the plus sign. So this guy's at, what is this, 4, 5, 6? That's at 6. So we'll set op pause to 6. We'll set left op to left op plus right op. So that's 132. And then we're going to set right op equal to the empty string, so we can rebuild it. All right, so those are the things that we need to do there. And then finally, we need to set I equal to op pause, so that when we loop back up in our loop, it adds 1 to I, making it op pause plus 1. So we can start building our next right op. Make sense? All right, so let's go back in here. So we need to make this second loop here a little beefier. And we got to do some extra stuff in there. So I'm going to go ahead. I'm going to steal, actually, just for paranoia's sake, let's just copy the XML so we have a starting point. Okay, so I'm going to steal this if statement from up here. Actually, I'm actually just going to steal this part of it. And we'll drag a new if statement in here so we don't have to remove as much stuff. All right, so we're going to go to our logic. We're going to grab an if. And we'll put the if right above that guy. And the thing we're going to paste in here is this guy. So in our formula, at bucket I, if that guy's not equal to a plus sign, then what do I want to do? I want to append it to my right op. All right. Else, if it is equal to a plus sign, that means I just finished the current right op. And I need to do some math. And that's what we just explained here. I need to set left op equal to the current math of left op plus the current number in right op, storing the result back at left op. Then I need to set op pause to a new number. Then I need to set I equal to op pause, so that the next time through this loop, the next time we spin back up in this loop, I has now shifted forward to its new spot. Okay, so we can start reading in another right guy. Okay, so if I'm in this else, that means that I need to do some math and store the result back in left op. All right, and the way we do that is we can steal this guy right here. In fact, let's just, I'll just copy it for right now. So we took advantage of not having to convert these guys before, right? We actually didn't even use our function up there in the end. We just multiplied it by 1 because the time sign isn't used by JavaScript. So this will get us, our current value of left op and right op, and we'll set that into our list. Then we're going to take the math we did with that, and we're actually going to set left op equal to that math. All right, so we get our current left and right op, put them in a list, then we add our current left and right op, together, and we store the result inside of left op. Okay, then we need to set right op equal to the empty string. So we're going to zero that guy out. So we zero right op out. Then we're going to set op pause equal to I. At this point in time, I is the current position of the plus sign. We're going to let the loop add 1 to it. Okay? So we're going to set op pause. This is all still happening, not in the loop. Is somebody going to tell me that? That all happens right there. Left op is going to be equal to the sum. Right op is the empty string. Op pause is going to be equal to I. All right, op pause is equal to I. This is all happening inside the else of our right op loop. So we keep building a right op as long as we're not looking at a plus sign. As soon as we do hit a plus sign, then we come and do this crap where we do some temporary math, store the result back in left op, zero out right op, set op pause equal to I. Okay? And then ultimately, and really we probably didn't even need to set op pause to anything because we only actually used op pause one time up here in our loop. And this only happens at the very beginning of our loop. But we're going to set it because we might need it here in a few minutes for our next step. All right? Doesn't hurt to remember where our op pause is. And then ultimately, we're going to then set I equal to op pause. All right, now we can make the argument that these two lines are literally waste of time. We set op pause equal to I, then set I equal to op pause. These guys are already equal to each other. Well, op pause is not equal to I, but I is already equal to op pause. So this line right here is definitely redundant. I already is equal to op pause. We just proved it right here. Okay? Not going to hurt anything, but definitely not needed. We already have I set to where we want it to be. Okay, so I is already at bucket 6 in this case, pointing right there. The next time through our loop, I will get positioned right here at the beginning of our next right op. All right? So we're going to keep track of op pause, however, just in case we need it again later on. So now we will spin back up through our loop, and we'll start building our next guy. So in the event we hit a plus sign, build a list out of our two numbers, set left op equal to the sum of our two numbers, zero out right op, store op pause just in case we need it at some later point in time, spin back up. Our loop keeps going as long as we still have string left. Okay, loop keeps going as long as we still have string left. But at this point in time, we just read in the 125, we just read in the 7, this is 132. We started, as soon as we read in, well actually let's go back to the 125, now we can just walk our logic. So 125, we hit the plus sign, then we go into our logic for reading in our right operand. We read in the 7, and then we hit a plus sign. What do we do when we hit a plus sign? Well, we add our two numbers together, storing the result back in left op. We zero out right op. We set op pause equal to the position of where we are, which in this case was 6, right? And then I is already equal to op pause. So we don't really even need that in there. We just know that that's what it's currently equal to. All right, Then we loop back through our loop. I becomes 1 greater than it was, which puts us right here. Now we read in the 1, we read in the 4, so this all goes into right op. The zeroed out version of right op. We're not building it on top of our 7. That's why it's important that we get rid of our 7 after we've done our math. So we get our 1 and our 4. Then we hit another plus sign. What do we do when we hit a plus sign? We add these two things together. So this is 146. Store the result back in left op. We zero out right op. Op pause is now, this is 6, 7, 8, 9. It's now equal to 9. I is also equal to 9, but when we loop back through the loop, 9 becomes 10. Okay, 9 becomes 10. So now we're sitting right here. We read in right op. So this is 10 for right op. Then we hit the end of our string. Okay, what does it mean if we hit the end of our string? That means that this loop right here has now naturally ended. We've stopped manipulating I internally in that loop. So that loop has naturally ended. So when we now fall past the end of the loop to right here. And what does it say to do? It says create a list out of our final left op and right op. These two guys right here. Add them together. So this is 156. And ultimately return the sum of those. So we'll return 156, which is what we should get out of this, correct? So I could steal this code. We'll pass this in here. I'm going to go ahead and steal our XML just in case. Go ahead and run this, and there's our 156. Make sense? Okay, now, to reinforce what we talked about last time, if you just sat down and tried to write this, you probably found it extremely difficult. How many of you were in that boat? I should see most of your hands. It's my guess. Okay? Should have been very difficult because at this point you're just looking at a wall of blocks. And as convenient as Blockly might be, when it starts getting this big, you start losing losing the details in the forest, right? Okay, so that's when you really need to go back here and solve the problem on paper. Even if this math seemed a little bit hard to stumble upon, even if you think that, oh, well, I maybe couldn't have come up with that, wouldn't you still agree that this was far easier for a human being to conceive of than this? Definitely a true statement, right? Okay, so always solve the problem as a person first. Give yourself some variables, fill them out. Create the magic trick by hand, then go convert it to Blockly. Make sense? All right, so, with this in mind, we could just keep adding stuff onto this to our heart's content. Plus 1421 plus 17 plus 2188, and still works. Okay. This works for, there's probably some limit to the total size of a string or something like that. I guess we can build an input for this. That might actually be kind of fun. That'll be a nice little in-class exercise. Let's say I want to build a random string in that format. I want to generate a formula. Okay, so that means we already have inside of math, we already have the ability of getting a random fraction, right? This gives us a number between 0 and 1. Is that correct? Okay. How could I make that a number between, let's say, 1 and 1,000? So just real quick here, I'm going to go ahead and we're just going to do another print. We're going to print a random fraction. We'll just run this real quick. We're interested in the second value we get. So there's our 0.07332. So it gives us a random number between 0 and 1. How do I make that a number between 1 and 1,000? Go ahead.
If you go under math or where it can be greater than or equal to.
All right, I'm going to stop you. We're no longer in the world of Blockly. I just gave you a random number. I have a number that looks along like that. How do I turn that number into a number between 1 and 1,000? It's just a math problem now. It's nothing to do with programming, nothing to do with Blockly.
Multiply by like 100.
Okay, so if I multiply this by 100, what would I get?
11.
11.23, blah, blah, blah. So you want to multiply it by 100? Okay. So now I get a number like 11.23. Okay, so if I multiply it by 100 every time, what's the largest value I can ever get? What's the largest value this can be? I think random is non-inclusive, so it would be 0.999999999. Just about 1, right? Just about 1. So the biggest this number could possibly be is 100, correct? So if we want it to be between 1 and 1,000, we multiply it by 1,000. All right, so we'll multiply this by 1,000. So now this is going to get us some number between, the smallest number we can get here is 0.000000. Correct? A 0 with a bunch of zeros after it times 1,000 is what? That's 0. All right. And we can even say we'll support zeros in this. So that's going to be 0. The biggest number we can possibly have is 0.999999999. So what's this going to be? This is going to be 999.99. Something like that, right? Okay. Can our random fraction be negative? Let's find out. Let's see if it's a number between 0 and 1 or a number between -1 and 1. So let's go and let's just maybe make a quick little loop. We'll do it 10 times. It should be enough to see if we get negative numbers out of that. All right, so there's our first. That's positive, 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 positive. All right, so based on our definitive test of rolling the dice 10 times and never getting a negative number, and also based on my experience that typically random number fractions like this in most languages, it's usually a function called like math.random, gives you a number between 0 and 1. We can, with confidence, say that this is always going to give us a positive number. Okay? So now, having said that, we can take whatever number it gives us, and we can add or multiply it by 1,000. And that will get us some number between 0 and 999.99. Fair enough? All right. Now, how do I make sure that's a whole number? Round up, it's fine. So realistically, we're going to to ever get a 0 out of this, we're going to have to hit the lottery. Right? You saw these numbers that came out of there. This was, it's probably harder than the lottery. So this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. We're going to have a 0 followed by 16 zeros randomly generated. Each of those places, 16 is going to be, we have 10 options, right? So we really have 11, what did I say, 16? We have 17 total spots. Each spot can be a 0 through a 9. So that is how many random things? We have 17 to the 10th power. Is that right? So that's thousands. millions, billions, trillions. So about a 1 in 2 trillion chance of getting a 0 out of this. All right? And since he wants to round up instead of just round, we're likely never going to get anything below a 1. Make sense? We should actually probably just put a little flag to, like, if you get a 0 out of this, print out and go buy a lottery ticket. All right. Okay, so now what we can do is we can go ahead and round this. So we're going to use this guy, and we're going to use the version of this guy that rounds up. And we're going to round up a random fraction. But the random fraction we're actually going to round up is going to be based on a math problem. And that's going to be this random fraction times a number. And the number is going to be 1,000. Okay? So we're going to, whoa, dangerously close to the garbage can. This is going to be an inflatable boat pop all over again. My wife was cackling. It's very disheartening. All right, so we're going to go ahead and print the rounded up version of our random fraction times 1,000. And we'll do that. Let's just so we don't have to hit OK so many times. Let's just do this 3 times. So there's 379, 925, 328. Seems to be the right ballpark. All right, so now we have the ability to generate a number between, realistically, we'll say this is 1 and 1,000. Realistically what we're generating. Okay, we could guarantee it by throwing like if statements in there, but let's just keep this as simple as possible. Worst case is we get a 0 and we wasted a plus sign, right? 0 plus anything is just going to be the anything. Okay, so I can now generate a number between 1 and 1,000. Now, I also now need to build a string. So I'd like to build a string by saying I want a num, followed by a plus, followed by a num, followed by a plus, followed by a num, followed by a plus. So many times. Make sense? So how do I build a string that is a number followed by a plus followed by a number? Let's start off with just that. So I want to write a function that generates 2 random numbers and builds the string that is the first number, followed by a plus sign, followed by the second number.
Make list with limiter plus from text.
All right, so let's come up here. We'll throw a new function out here. We'll have this guy return. Call this guy build formula. Build formula. Okay, and build formula is going to, well, we won't have it take anything in. We'll just have it do everything in-house. All right, so you want to, we're just going to do it simple initially. We're going to say we want to build a list. Just real quick, can we can really do it with text too, can't we? I think so.
I was just saying because the list one already had the delimiter and then you just added.
I guess it doesn't necessarily matter. In the end, we want to be we want to add stuff onto a it's actually probably just a horse apiece, realistically. So we want to create a list with the rounded up version of one number, followed by the rounded up version of another number. Actually, here's the reason I was suggesting let's find out if strings will let us do it. I'm going to create text. Can I make text out of this? I can. And then I'm going to make text out of the plus sign. And then I'm going to add one more dealie. Won't that just build it for us?
Yeah.
So we'll start with that. So this will do exactly 2, right? This will just create a 2 random numbers. So now what we're going to do is we'll get rid of this repeat thing. Instead of doing math with this, we're going to go ahead and, just to prove it's all working, let's create a variable. Let's call set call this guy input. We'll set input equal to the function build formula. And then what we want to do is we're going to print the current value of input. I'm sorry, we're going to print do math of the current value of input. Get rid of this guy. All right, so that's really our program. We'll set input equal to the result of build formula, and then let's actually, just for the sake of anything, let's go ahead and print out our input just so we can see what was generated by our function. So we're going to set input equal to whatever build formula returns. Then we'll print out what that input was, which should be some random number between 1 and 1,000, followed by a plus sign, followed by another random number between 1 and 1,000. Then we'll actually pass that input into do math and print out the result. Make sense? Go ahead and run this. So we get 772 plus 229, which is 1,001. All right. Now, we want build formula to build us a random formula with so many numbers in it. Maybe we can randomly generate a number of numbers. So maybe we do between, actually, quick question for you. Will that work? Could I just pass in a 5?
It's looking for a plus.
Well, go back up to our code up here. If I just pass in a 5, it's going to keep going until it finds a plus, right? But potentially up to the length of the formula. So I read in the 5 into left op. I come to this loop, but this loop's not going to do anything, right? We're off the end of the string. So now I drop past that and I say, create a list out of left op times 1 and right op times 1. Well, right op is currently what? The empty string. What will the right op of that be? Let's run this. Gave us a 10, which means that it did. In here, we created a list of left op times 1, right op times 1. So right op was the empty string. Let's look at the JavaScript code that produced. Do math. Yeah, here's where we build them into a list. But right op should be the empty string there. So it looks like the behavior of this was, since this guy was the empty string, you couldn't multiply that by 1. It just doubled left op and said, since we tried, well, actually it probably didn't double left op. It probably just created a list with one element in it, and we said list at bucket 1. It just gave us the only element that was in the list. That, in any case, not the correct output. We could ask a question here, right? We could ask if right op is equal to nothing, it's equal to the empty string, just go ahead and return left op. Throw a quick question in there before we do this. If logic variables right op empty string, then we'll go down and we have a return somewhere, don't we? There's it in loops. Oh, this probably would have been kind of helpful for our 1 to 1,000, but we did ours in a more mathy, cool way. So we'll leave it. Where's my return? Oh, if, yeah, we have to use a special if. If this is true, then just return left op. We can get rid of this, but insert this. All right, so we got to clear this little filter here. So as we drop out of our loop, we'll ask if right op doesn't have anything in it, just go ahead and return left op, which in this case should just be a 5. Row. Math is 5. I broke the world. All right, left op is the empty string. Go through, fill up. Close that. Oh, it's because op pause is still equal to 0. We never actually changed op pause here. So we never actually got into this else. So actually, we can just do this. We can move this if statement. Row. Drag it up here. Instead of doing it afterwards, we can just ask right after the first thing. If we're only dealing with one number. And we can ask if op pause is equal to a 0. Then return left op. We can get rid of this if. Now it should just be a 5. There's our 5. All right, so now our function works for things as small as even just a single value. For our homework, we just want to build formulas. Should be a little bit easier assignment. Okay, so now instead of just creating text that's a single number followed by a plus followed by a single number, now we want to randomly generate a length of maybe up to 10 numbers. You know, it doesn't matter if it's 10 or 1,000. It's going to be the same code. So now it should be, let's just say you're going to do 8. It should randomly generate a number followed by a plus, followed by a number, followed by a plus, followed by a number for a total of 8 numbers. Okay? But you're going to have to know to stop and not put an extra plus sign at the very end. That's the challenge on this assignment. Make sense? All right, so homework assignment, build formula for generating a string in the proper format for up to 10 numbers. Okay? You could either randomly generate it or you could just take in a parameter. Doesn't matter, it's the same logic. I'll see everybody on Wednesday.
So we did ours different. differently? Is there anything to add about the way we did it? Like, we were trying to figure out the whole loop thing, and so we ended up repeating everything with the math in there. Right?
Oh, I mean, that's okay.
Okay. Yeah, that's all we had. So I don't know if that's just.
I mean, that's okay. I don't think there's anything wrong with doing it that way. Let me stop the recording here real quick.